Hi. All right, so in our last video we talked about negative exponents and we used some examples, for instance 3 to the negative second. So using that area model, we saw that 3 to the second is the same thing as 1 over 9. All right, now remember 3 to the positive second, 3 squared, all right, is going to be 9. However, 3 to the negative second is going to be 1/9, okay? And that's remembering because we're having a negative here. A negative exponent means that we're dividing. It's repeated dividing. Whereas here, a positive exponent is repeated multiplication. So that's why here, there are 9s in common in both of these. But here it's 1 over 9, and here it's just a whole number, 9. And we also used another example of 3 to the negative third, right? We said 3 to the negative third is 1 over 27 in the last video. And then 3 to the positive 3, all right, is just a regular whole number, 27, all right? So we saw that when we have negative exponents, we don't have negative numbers. What we have is fractions. So you can think of negative exponents really evaluating to fractions, all right? So we did a whole area model to sort of come to these conclusions. But fortunately, because using the area model and all of that thinking behind it takes a lot of time, it's important to know why we get to these ultimate evaluations. It's very important to know why, so that's why the last video was important. But when we're dealing with problems that we want to move through efficiently, there's a much quicker way to go from here to here, all right? Or from here to here. And so that's what I like to do in this video, all right? Do you notice something that's common? Here the 9s are common, and here the 27s are common, all right? So what is another form of 9? Well, we could write 9 as 3 to the positive 2, 3 squared. 1/9 is the same thing as 1 over 3 squared. And 27, all right, we know that 27 is the same as 3 to the third. So what we could do here is replace 27 with 3 to the third, all right? So that's our quick rule if we wanted to come up with a quick way of being able to get from here to here without drawing a big area model. We could just say this. Well, in the end, what we're really going to end up doing is we're going to take away the negative, all right, of the exponent, but then we can write it in its positive version. So negative 2 here turns into a positive 2 as long as we make a fraction out of it. We put this entire expression right here all in the denominator, okay? So 3 to the negative 2 is the exact same thing as saying 1 over 9 or 1 over 3 to the positive 2. So here's the quick rule. If you want to take a base that has a negative number, a negative exponent, and you want to rewrite this expression in a way that has a positive exponent, the way that we can do that is turn this into a fraction where we change the negative exponent into its positive alternative, all right? So 3 to the negative 3 is equivalent to 1 over 3 to the third, all right? And so we can use that rule for any kind of situation. If we're using 5 to the negative 2, a quick way to write this with a positive exponent is 1 over 5 to the positive 2. All right? 5 to the 8th, 5 to the negative 8th would be rewritten as 1 over 5 to the positive 8th. So you can do this for anything, really. Let's go on for more. I mean, I'm just going to do a lot of examples like this just to really show you that it could work with anything. Let's say 45 to the negative 3rd. That equals 1 over 45 to the positive 3rd. Okay? How about 28 to the negative 32nd? All right? That would be the same thing as 1 over 28 to the positive 32nd. All right? So this is a really quick way for us to go from a form that has a negative exponent to rewriting it with only positive exponents. All right? Now this is important. This skill is important because when we are simplifying expressions, all right? When we're simplifying expressions, the final form of our simplified expression simplifying expressions must have positive exponents in the end, okay? So we could change this. We could say a simplified expression must have positive exponents. Simplified expressions must have only positive exponents, all right? If they're negative exponents in your final answer, it's not considered fully simplified. Another way to express this is simplified expressions cannot have negative exponents. Simplified expressions cannot have negative exponents. If you have an expression and it still has a negative exponent in it, you must rewrite it in some way so that its equivalent form has positive exponents. Okay? So let's say that you were simplifying a problem. Let's say you were given something that looks like this. 4 to the, 4 to the 3rd divided by 4 to the 5th. And the instructions were simplify. Not evaluate. I don't really want to know what 4 to the 3rd is, and I don't really want to know what 4 to the 5th is. I want to simplify it. So I'm not evaluating it. I'm not actually multiplying 4 times 4 times 4. I don't want to know what that is. I just want to write this expression in a simplified form. Okay? Our rule to do this is when we have two bases that are the same and they're being divided, which they are in this case because this is a division symbol, this fraction symbol is a division symbol. When the bases are the same, you subtract the exponents. All right, so bases are the same, so we'll keep the base and we'll subtract the exponents. 3 minus 5 is negative 2. So 4 to the 3rd divided by 4 to the 5th is 4 to the negative 2nd. All right, we are not done with our simplifying. We're not done because here we have a negative exponent, a negative 2, and therefore our work is not done yet. It's on the way to getting to the complete answer, but this would only get partial credit on a test or quiz. All right, it will only get partial credit. For us to completely simplify this fully, we do not want any negative exponents. All right, so I'm going to rewrite 4 to the negative 2 over here. So if we have 4 to the negative 2, let's say you did all that great work and you got 4 to the negative 2, you're almost there. You're almost there. What you need to do is express 4 to the negative 2 with a positive exponent. So we just learned that you can write this expression here with a positive exponent. Remember, it's 1 over 4 to the positive 2. This is your complete 100% full credit answer if you put this on a test. So this would get partial credit, but here we don't have any negative exponents, and so 1 over 4 squared is perfect. Again, since we're simplifying, we don't have to evaluate what this is, all right? I know that 1 over 4 squared is 16. 1 over 4 squared is 1/16. I get that, but we weren't asking you to evaluate it, we were just asking you to simplify, and that's why you can leave your bases with exponents. You can totally leave it with exponents in a simplified exponential notation, as we say here. So this is actually the best answer in this case. All right, so in the next video, we'll practice some more.